Hey guys, I miss you. It's only like the third day, second day. I don't know. I'm losing track of days. It's been terrible. I miss you so much. Anyway, let's get working. Prime and composite numbers. Probably one of my favorite lessons. Actually, they're all my favorite. Central question. How can different fractions name the same amount? So different fractions name the same amount. 1/2 and 3/6 names the same amount. We'll get further into that as we go. I am thinking of a number that is greater than 50, less than 60, and can be divided by 5 and 11. What number is it? I'm only going to give you about 30 seconds to work on this because you're all so smart and you already know the answer. All right, what is it? Who can tell me what's that number? Yes, it is 55. 55. Let's see if we're right. Dun, 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 we're right. Okay, today what we're going to work on is how can you be sure that a number is prime or composite? We're going to talk about these two, what prime is and what composite is. Using 13 objects, form as many arrays as you can. Record your result. Then form as many arrays as you can with 14 objects and record your results. So I'm going to show you one quick way. It's going to be a little hard because my screen is very small. But with 13 objects, there's only really two ways. You could only do 13 across. Blah, 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 right? Or 13 up and down. Okay, so 13 across or 13 up and down. Now 14, you could do 14 across, 14 up and down. But you could also do 7 across and 2 down. Or 2 across and 7 down. Okay? So the reason I'm showing you that is because I want you to understand that 13 only gave you 2 different arrays, whereas 14 gave you 4 different arrays. And I think you'll remember we talked about this a lot when we did the picture thing. And we said what were different ways that you could arrange the pictures. Okay, so let's move on. So here it has 1 by 13 or 1 by 14, 2 by 7, 7 by 2, 14 by 1, which is kind of the same thing that I drew. All right, we're going to skip over this one. Whoops. All right, this is Math in My World, and now we are in your book, which is, let me turn to my page. This is page 491, and we'll be working 491 and 492. So let's look at the example. It says, Blair is arranging 18 cupcakes on a shelf. Find the factors of 18. Use arrays to find the factors. So how many do we have going across here? Whoops, sorry. How many do we have going across here? We have 18. And we have 1 down. So 1 by 18. Then we have 2 down. And we have 9 across. And we have 3 down. And we have 6 across. So the factors of 18 are 1. You know me, I like to go in order. 2, 3, 6, 9, and 18. 18 has more than 2 factors. It is a composite number. So let's look. Composite numbers have more than 2 factors. So think about what we used with 13 and 14. 13 is a prime number because it only has 1 and itself. 14 is a composite number because it has 1 and itself plus other factors, 2 and 7. If a number has more than 2 factors, it's composite. If a number is prime, it only has 2 factors. There's one exception. the number 1. It is neither prime nor composite because it only has itself. Okay, let's move on. So here it has our definitions. A prime number is a whole number with exactly 2 distinct factors, 1 and itself. And it gives you examples, 2, 3, 7, 11. Now, one thing I want you to understand, just because a number is odd doesn't always mean it's prime. Yes, there are definitely more odd numbers that are prime, but not all odd numbers are prime. Composite number, a whole number with more than 2 factors. Any number that ends in 0, 2, 4, 6, or 8 is composite because 2 can go into it evenly. Neither prime nor composite. 1 only has 1 distinct factor, and that's it, just the number 1. Sarah's at the park. She counts 73 kites. Write the factors of 73. Tell whether it is prime or composite. So this gave us something, and it gave us 2 little lines. So we know that, 1 and 73 are its factors. Since 73 has 2 distinct factors, it is a prime number. Okay, so make sure that you're following along in your book and you're writing this down. This is on page 492, example 2. Let's look at example 3. Find the factors of 1. Oh, they're trying to trick you already. Since 1 only has 1 distinct factor, it is, neither. All right. We're all good? Okay, neither prime nor composite. Okay, here's our guided practice, guys. We've got through this very quickly. Tell whether each number is prime, composite, or neither. How about number 5? What do you think? Prime, composite, or neither? It is prime. It only has 1 and itself. How about 15? What do we think about 15? So we know that has 1 and 15, 3 and 5. So it is composite. How about 21? It's an odd number, but just because it's odd doesn't mean that it's prime. 21 is a composite number. 1, 21, 3, and 7. How about 31? It's odd. So we know that numbers that are not even are more likely to be prime. Let's think about it. Is there a number that we know that gives us 31 as an answer? 1, 2, 3. 3 times 10 is 30, but not 31, so it's prime. How about 26? Well, we know that it ends in a 6. And if it ends in an even number, it's composite. How about 61? What's 61? Well, let's see. 6 times 10 is 60. So I can't think of anything. So it's prime. It doesn't end in a 2, 4, 6, or 8. Let's see if we're right. And we were. All right, boys and girls, I'm going to give you your independent practice. Here's what I want you to do. You are going to do numbers 7. Oops. Ooh, that was not good. All right, here we go. 7 to 17. Odd. Okay. And you're going to do 19 to 25. Okay? Everyone clear? 7 to 17 odd and 19 to 25. Don't forget, boys and girls, you need to do your park packet 1 to 5. And I also will be sending your formative assessment through Dojo. I miss you. I hope everything's great. Don't forget you need to do your homework too. I'm sorry, I almost forgot. How did I forget my homework? Please do pages 495 and 496 for your homework. If you have any problems, let me know. We're here for you. Okay? Thank you. Bye.